Hello guys, welcome to day 3 of fundamentals of mathematics, and in today's video we are going to use all the laws we have learned in day 1, day 2 and day 0 to answer past questions. And this question today is from Cameroon GCE Board 2020 Additional Mathematics Paper 2 question 4, which says that the set S is equals to A, B, C, D, and the binary operation star form the group. Copy and complete the operation table below. From the table, state the identity element, and the last part says that we should state the inverse of each element. Guys, before we continue with this question, I want to explain what it means by group formation. So if an operation and a set forms a group, it simply means that all the laws we have studied in day 1, day and day 2 are applied, are valid. What are the laws we studied? The first law for group formation we are going to see is the law of closure. Closure simply means that the numbers that we are concerned with are the same number that will be found on the table, meaning that the numbers we are concerned with are A, B, C, D from the set A, B, C, D, right? So this table must only contain the letters A, B, C, D. If there is another letter in this table, then the set will no longer be closed. So if there is a letter, let's say F, then this set is not closed. So we expect that when we are filling this table, we can only have the letters A, B, C, D. That's what we mean by closure. The second part of the closure means that in every row or every column, there should be only one letter A, one letter B, one letter C, and one letter D. There should be no repetition. That's the second law for closure. For instance, let's look at this column here. In this column, A star A is D, B star A is C, C star A is A, D star A is B. So we have here D, C, A, B. So in that column, there is no repetition. So we expect all the elements of that table to be A, B, C, D. The next aspect, the next law that we are going to look at is the law of associativity. If you don't know the law of associativity, please watch day 1 fundamentals of mathematics day 1 on the math time questions and answers. So associativity simply means that what if we have three numbers A, B and C, then A star B, the result star C will be the same as B star C and the result star A. So if it's addition, then we'll replace that addition by what? The star, and if it's multiplication or any sign, we'll replace it with what? That star. So in this case, that is associativity. So the next law that we are going to test for closure is the law of commutativity. Commutativity simply says that A star B is equals to B star A. This law is very important when we'll be completing this table. You will see how we are going to apply it. So stay with me and hold on tight. The next thing we are going to look at is identity element. If this table, this set forms a group, then we should have only one identity element. If we have more than one identity element, then it doesn't form a group. And what is identity element? Based on addition, we saw what? Additive identity, and based on multiplication, we saw multiplicative identity, where we say multiplicative identity is 1 and additive identity is 0, because when we add 0 to any number, it does not change the identity of that number. Remember, right? Okay, let's look at the next is the inverse of an element. If this table forms a group, then each element must have what? An inverse. And we said that what? If minus A is the inverse of an element, then minus A star that element A will give us what? The identity element. We said when we are dealing with addition, the inverse of a number is simply what? The opposite of that number, and the opposite here will means what? We change the sign of that number. And for multiplication, when we are dealing with the inverse of a number is what? The reciprocal of that number, meaning that what? We invert the number. So these are the laws that we need to test for us to know if a group is closed. But we don't need to test these laws, since the question says that what? The set and the binary operation star forms a group, meaning that what? The question is already telling us that what? They have tested the law for closure, associativity, commutativity, identity element, and inverse, and all these laws apply in this case. So if they apply, then it forms a group. Now let's use these laws to complete the table above. So question B is what? We should question A rather is that we should copy and complete the table using the informations we have. So that's the table that we have copied. Now let's start completing the table. Now if we look at this row here, we have A, B, D. So what do we have? We have A star B. That is the entry that we need to fill, A star B. But we already know that what? B star A here is C. If B star A is C, then A star B should be C because of the law of what? Commutativity. We have said that A star B is equals to B star A. So if B star A is C, then A star B will be C. Simple, right? Because of commutativity. Now, because of the law of closure, what do we have on this space here? Since we already have A, C, D, and we have said for a set to be closed, we need to have only the elements A, B, C, D, and the elements in each row or in each column must be single element, meaning that what? They should not repeat. So we already have A, C, D. For it to be closed, we only need what? There is only B that can be there because we already have A, C, D, right? So the only lacking element is B. So in that case, B is there. Understood, right? So now we have B star C. B star C here we need to fill. Let's look. Do we know C star B? C star B is B. So if C star B is equals to B, then B star C will be what? B, sorry, because of commutativity. Or you can also use another method by saying that what? If this column if this row we already have C, D, and A, then what will be lagging here? Will be lacking B. Or you can use what? Commutativity law. So if you use commutativity law, then you will say that what? B star C is B, so C star B will be B because of commutativity. If you use the law of closure, then you will say on this column, on this row, sorry, we already have C, D, A, then what will be lacking here is B. So here again we already have A, B, C, so what will be lacking here is nothing but D because of the closure law, right? Okay, if that's the case, then we already have B, C, B, A, then what will be here? We can either have B or C, but we don't know what we have, so we need to what? Look for another law to make this easier. So we'll go for what? The commutative law again. So in this entry here, we have C star D, which we don't know. So do we know D star C? D star C is D. D star C is D. Therefore, C star D will be D because of commutative law. Okay, so it will be D there. So now that we already have A, B, D, we are lacking C, so C will automatically be there. Or you can as well use commutative law. No, we can't use commutative law in this case because there is only one D star D, which is this entry. Okay, so guys, we have used the law of closure and commutative law to do what? To complete this table, and that is it there. Now the B section says that we should look for the identity element. From this, what we have here on the left is going to guide us on how to get the identity element. We said that what? If E is the identity element, then if we pick any element from this table, let's say A star, the identity element will be equals to that element, identity element star that element, to give us that same element A. So if we pick, let's say we pick B, what is the identity element? We'll look for B star what element will give us what? B. So under B we have B here. So B star is identity element, which is C, is going to give us B. Let's check for A. A star what element is going to give us A. So if we look under A, we have A here. So A star C will give us what? A. So C is the identity element. Let's look for C. C star what will give us the letter C. We go under C. Where is the letter C? C is here. So C star C will give us C. So C is the identity element. So we have seen that what? C is the identity element, because if we choose any element on the table and we perform the operation star that element, will give us the element itself, meaning the element will not change. Let me give you a trick on how to look for the identity element easily when you cannot remember this. So the trick here is that if we are looking for the identity element, then under the identity element we have the element A, B, C, D. So under the identity element, the elements will repeat in that order, A, B, C, D, because they will be unchanged. Identity element says that what? It will leave that element unchanged. So let's look at under C. Under C here we have, so the identity element is C. Under C here we have A, B, C, D. So in that same order, A, B, C, D, right? Under C here, A, B, C, D. There is C here too. Let's look under that C. We still have A, B, C, D. So we see that what? Under C, the elements remain unchanged. Why? Because C is the identity element. So C is the identity element. Now let's look for the inverse of each element. So the inverse of each element, which is the C part, is simply that what? If minus A is the inverse in this case, then A star the inverse will be equals to the inverse star A, which is the identity element. So we simply go under any element where we see the identity element, then the corresponding element or the corresponding letter is the inverse. So let's look at A. Under A, where do we see the identity element? Identity element we know is C. So under A we see the identity element here, which is C. So what is the corresponding letter? B. So A star B will give us the identity element. A star the inverse, which is A minus, and in this case A minus is B, because the identity element corresponds to B here. So A star B will give us the identity element C. Therefore we say that B is the inverse of A. Now let's go for B. Under B, where do we see C? C is here. What letter corresponds to C? A. So B star A is C. So we say that what? A is the inverse of B. Right? Let's look for under C. Under C, where do we have the identity element? Here. C is here. What corresponds to the element? C. So C is the identity element of C. Let's look for the inverse, sorry. Let's look for the inverse of D. Under D, where do we see the identity element? Identity element is C. Here is C. So we see the identity element here. Where is the corresponding letter? The corresponding letter is exactly D. So we say that what? D is the inverse of D. So guys, that's how we use the law of associativity, closure, commutativity, identity element, inverse to solve mathematical problems under operations. So guys, don't forget to like, comment, and share this video with people who need it. Stay with me and watch out for day 4 of fundamentals of mathematics, which will be unit 2. And in unit 2 we are going to be talking about the order of operation, things like but mass. In case we have more than one operation in an expression or in an equation, how do we handle this? This is a problem to many people, but we are here to help you, give you the insights to all mathematical problems giving you headache at school. So guys, watch out for day 4 and stay blessed. Bye bye.